What does it really mean for an AI to think? Today, we're diving deep into interview.net distributed systems, interview.net distributed systems, the strategic framework for senior .NET architecture interviews. The industry shift, .NET career growth, now depends on distributed reasoning. Interviewers probe state partitioning, consensus, failure recovery, and specific .NET stacks, Orleans, Dapr, YARP. The preparation landscape is fractured. No integrated system teaches trade-off reasoning. The interview is a design exercise, not a trivia test, articulating why Orleans virtual actors over raw Akka.NET or how Dapr resiliency complements Poly separates senior engineers. This framework encodes that articulation as instinct, but here's where it gets interesting. The preparation CIling. Current preparation fails the .NET distributed systems interview. Platforms like LeapTut optimize for algorithmic pattern matching, ignoring the architectural reasoning demanded by staff-level loops. Scattered tutorials introduce Dapr, Orleans, or Poly in isolation, never synthesizing them into a coherent decision framework. A candidate can recite the CAP theorem, but cannot justify eventual consistency in an event-sourced order. Pipeline with Azure Cosmos DB and Service Bus. Interviewers see facts, not fluency. The ceiling is real. So what's the real problem? Let's talk about the root cause. Siloed knowledge. Distributed systems knowledge in .NET is siloed. Core theory, CAP consensus. Replication is taught through academic or cloud-agnostic lenses. .NET specifics virtual actors in Orleans. Stateful services in Service Fabric. Sidecar patterns via Dapr are documented as product docs, not as architectural decision tools. The missing link, a framework that maps theory to .NET runtime, realities for interview contexts. This separation forces candidates to mentally translate generic patterns into platform-specific trade-offs under time pressure. The result, shallow answers that miss .NET's native strengths. This raises a critical question. Breakthrough framework, interview.net distributed systems, a framework, not a course. It integrates foundational distributed principles with .NET's unique ecosystem, Orleans virtual actor model, Dapr building blocks, Service Fabric stateful partitioning, YARP reverse proxy, Poly resilience policies. Each concept is paired with an interview-proven mental model. The system builds the instinct to navigate trade-offs, consistency versus latency, orchestration versus choreography, stateful versus stateless services, all in .NET context. It transforms scattered knowledge into a repeatable decision tree. Candidates learn to articulate why a .NET microservice, using Dapr Sidecar for PubSub and Poly for transient fault handling, outperforms a generic solution in interview whiteboarding. Now let's zoom in on layered architecture stack. The framework is structured as a layered stack. Distributed foundations CAP, PACELC, time, consensus, replication, .NET distributed primitives, Orleans grain placement, Dapr state stores, Service Fabric replicas, YARP routing, design patterns, library CQRS, event sourcing, sagas, actor-based workflows, each mapped to .NET implementations, trade-off analysis, engine decision matrices for consistency, latency, throughput, cost, interview simulation scenarios, whiteboard prompts with .NET constraints. This layered stack eliminates the translation gap between theory and .NET reality. Here's something most people overlook. Core commandment mapping. Each module maps a concept to its .NET embodiment. Partitioning Orleans grains, Service Fabric partitions, Cosmos DB logical partitions, messaging Azure Service Bus, YARP, mass transit, Dapr pub sup, resilience poly policies, Dapr resiliency specs, Service Fabric retry, observability, open telemetry, application insights, .NET diagnostics, state management, Dapr state stores, Orleans persistence, EF core for event sourcing. Candidates learn the when and why for each technology, not just the what. This concrete mapping builds interview-ready recall. Think about this for a second. Progressive workflow. Learn, pop, simulate. Learn, apply, simulate. The system progresses in 3 phases: concept deep dive, interactive modules with .NET code snippets, e.g., implementing a Saga with mass transit and Azure Service Bus; applied lab, candidates solve constrained design tasks, e.g., design a leader election using Orleans and Azure Blob leases; timed simulation, a whiteboard challenge judged on architectural reasoning, not code correctness; feedback highlights trade-off awareness. This loop internalizes distributed patterns as instinct, not memorization, and this is where things get complex. Whiteboard reasoning scaffold. The framework provides a scaffold for system design interviews. When faced with design a real-time auction system, the candidate uses layered reasoning, data layer state partitioning, Orleans grains per auction, communication pub sub via Dapr, resilience circuit breaker per bid service with Poly, observability tracing. This structured decomposition prevents chaotic whiteboarding and demonstrates senior-level clarity. The scaffold is not a template, but a reasoning framework adaptable to any .NET Stack scenario. But here's where it gets interesting: measurable impact. Early data shows a 40% improvement in system design interview scores among beta users. Candidates move from citing definitions to structuring decisions. Hiring managers report candidates who think in .NET. Distributed primitives, a clear signal of production readiness. The outcome: offer rates increase, time to hire for senior roles decreases. Candidates who trained with the framework demonstrate consistent competence across cloud-native design, failure handling, and platform-specific optimization. So what's the real problem? Let's talk about the .NET Platform Edge. Generic system design prep ignores platform leverage. This framework encodes the .NET advantage. Orleans